Got it.
Really good.
Also depends on what taco I'm in the mood for.
What taco you're in the mood for. All right. You have specific taco moods.
Well, yeah, if I'm getting like a burrito or something.
Actually, sorry.
Specific.
Oh, yeah. Are there any in the pub still there? You can bring them over.
Sometimes I
Yeah, the chair. Right. See? Did you find some?
What?
Okay, there's more speed more. Oh,
sometimes I do chicken taco, sometimes.
Thank you. Yeah. What?
It's a junior lab rat.
Oh, maybe I clicked the wrong one. Good call. Hang on. I opened the wrong lesson. I already did that lesson. Need to open this lesson. See, they're right next to each other, so. All right, I'm gonna grab a drink real fast. Uh-oh. Yes, I know. Okay,
I love rich crackers.
there we go.
Yeah, they're still says junior lab rat.
It's not. It should be.
That brownie point in it. They pointed it out first. But this is the actual real lesson. No. I love rich crackers.
Sorry, Puppy. I needed a drink. He's looking at me like, why'd you leave me?
Why'd you leave me with the drink?
Yeah, really. These dudes. That's y'all. That's y'all. Okay, it's right. It's just the title page is wrong. All right, so my gang, my people. Everybody found rocks. Ozzy, no sir. Like, Play. Place. Take your time. Take your time. Thank you. Y'all caught my shirt, right? I'm wearing my girl's shirt. Yeah. Okay. So I gotta turn this on still, but while I'm getting it on. So you guys, everybody found a rock. Some of you found them the hard way. Some of you found them the easier way. But everybody found one, right?
Some of us found them on the extreme trail.
Yes, on the extreme trail, which is technically not a trail, but
Now,
it is now. I guess so. Make sure that's good. Okay. Turn that. There you are. Okay. So we're gonna do minerals today. And this is where we get into some of the pretty things. I like this part. This is a fun part. And eventually when we start getting into, like, this is all composition of the earth. I like the weather stuff and when we get into like earth movements. I really like all that kind of business too. But this stuff is neat because it gives you an idea of what's down there, what's under you, right? So there are actually 2 granite quarries very nearby. Do you know where they are? Anybody know where they are?
Nearby.
Nearby. Actually, I'll show you real quick. If you were to look at, whoop. My friend started his thing today. Oh no, not that. I hate this thing. It's in my way. Okay, come here. Come here. Oh my gracious. Hold on. This is in my way. What is that? Here we go. So if we were to look at like Google Earth and put us where we are, you can actually see the 2 granite quarries, and it gives you an idea of kind of where we are with regards to the sort of stuff that's beneath us, right? And actually the school where I used to teach was kind of on a hill, and there was a lot. Ozzy, hey, leave it. Place. Hey, there was actually a lot of metal deposit there, and we got more lightning strikes there than we typically get. So if you kind of back out of here, you can actually see the quarries pretty well from these aerial views. So one of them is the one that is up here by the hospital. Do you guys know where that one is? You might pass it. I think it was called the Lafarge. I don't know if it's still called Lafarge, but it's a granite quarry. They mine granite right there. And you can, if you drive down Ronald Reagan Parkway, you drive along the length of it right here. This is Ronald Reagan Parkway. But you can see how deep they get and they fill up with water. There's the one, there's one over in, I think it's in Dallas, Georgia. It's down 20 west. And that's the one where they filmed Walking Dead and Stranger Things, that quarry. So if you remember, like when Will was floating in the water, it was that quarry. The other quarry is, so where are we? Let's bring us back in. Where are we? Right there we are. Okay, so we're right here. The other quarry is actually over here in Johns Creek, a little further down. This one you can't see as well. If you know where like McGinnis Ferry and there, is that it? Nope. Where McGinnis Ferry and 141 connect, you'll find there is a big, there's like a big you know where the Taco Bell is? Anybody know where that is? The Taco Bell?
Which Taco Bell?
The one on 141, which Taco Bell says the kid. The one, oh, here we go. The one on 141 that's near Kohl's, and there's a Kroger and a Chick-fil-A. Do you know where I'm talking? Sort of. Okay. So it's right here. So not far from us again. So it's, you can see it. So this right here is the little downtown Johns Creek area. There's the Johns Creek Hospital. I don't know what it is about hospitals and quarries around here. But right here, this is the other one. And it's kind of hidden. You can't see it from the road. Like you can see parts of the other one. The other one in our old house, we could actually feel it whenever they would blow something up. But you can see it's not, that's not far from us at all. See, that's right there. So you should expect to find, some of you guys are definitely going to find granite. You got one here and one here. You can see them both right there and right there. So they're not far. So a lot of you are probably going to find granite. That probably would have been your, what you found. But some of you may have found something else. And if you found something else, like some of you may have found some shale, that probably came down the river, which is super cool, actually. All right, so let's talk about mineral characteristics. All right, so anybody want to define mineral for me? Ooh, look at the binders. Bailey, what you got? It's part of it. Good one. What you got, Piper? Oh, never mind. She changed your mind. All right, so mineral is going to be naturally occurring. They're not man-made. Inorganic solid with specified chemical composition and definite crystalline structure. So this means that inorganic, what's inorganic? Alex?
Not alive.
Yeah, not derived from a living thing, right? Never was alive. So I'm gonna have to put yours there because you're gonna get more on this one. So yeah, that's where it goes. There we go. All right, so yes, and then having a specific chemical composition would mean that it's a unique type of compound, right? There isn't another compound that's like it. They're all different. And then a definite crystalline structure, we'll talk about crystalline structure, but this has to do with how the molecules are arranged. So we just defined inorganic, so not consisting of or derived from a living matter. Why is carbon something we consider when we're talking about inorganic? When we talk about, what's carbon have to do with it? Piper?
It comes normally from like very hot compressed bones, I think.
That's where you get carbon, James?
All organic.
Yeah, organic matter typically is carbon based. For those of you who are in biology, remember we talked about the big long carbon molecules, the hydrocarbon chains and all that. Those are, yeah. What? So those, yes, those are the things those are the kind of molecules you find in living things. You're not going to find these in crystalline structure. So what's a crystal? How do we define crystal? All right, Liam.
Crystal is a solid in which the atoms are arranged in repeating patterns.
There you go. So arranged in repeating patterns. So you can kind of think of it like if you had Legos, like maybe the kind that are the right angle shape, you know what I mean?
Squares.
Not the squares, but the kind that look like an L.
Yeah.
The weird ones that you don't find very often. And you had to build a tower out of only them. You would have to use the same pattern, repeat it going up. Same thing if you had any other kind of a shape, or if you had square ones and the L-shaped ones. You would have to repeat the pattern to make your structure. So that's kind of how these work. Now, I want you to notice, we talked about the inorganic thing. I want you to notice this bit about boiling points. So there's a lab we do in chemistry or physical science, I don't remember which one, where we talk about organic and inorganic compounds. And so if I were to give you a tablespoon of salt in a little dish and a tablespoon of sugar in another dish, What are some ways you could tell them apart? Piper.
Scent.
Scent? Maybe. Sometimes salt can be a little metallic scented. What have you got, Caitlin? You could taste it. Okay, that's one thing you could do. You could definitely give it a taste, which is kind of a brave thing to do because typically we don't taste stuff in lab, right? What are you thinking, Bailey? You could try to see if it dissolves. So what if you put it in water? What's going to happen in both cases? What's going to happen? That's true. Okay. What do you got?
I have two things.
Uh-huh.
One, you can dissolve it
Yep.
and then check how well it conducts electricity. Salt will conduct much better than sugar water.
There you go. It's a good one.
Two, light them on fire
There you go. Why does the salt water conduct electricity better than the sugar water?
because they turn to ions.
Very good. You get the ions. Those free floating ions are very, very good for electrical conductivity. So what would happen if you were to heat the two of them up?
Sugar would combust, salt would just sit there and get warmer.
Yeah, your sugar's gonna melt too. So it's gonna melt and then it's gonna burn, right? But your salt is just gonna sit there and sit there and sit there because it has a much higher boiling point. And that's because the ionic bonds in it are much stronger and are harder to break. So think about that. You got a higher boiling point for these things, higher melting point. Sorry, not boiling point, melting point. And then there's another one down here. Which one was it? Oh, I can't remember. Oh, they're not biodegradable, right? Like if you take the molecules that make up wood, like if you take the cellulose molecules in the wood, they're not going to break. They're going to break down out in nature eventually, right? But if you take silica and put it out there, it's not going to. It's going to stay what it is. So there are two ways that we can form minerals, from magma and from solutions. So when minerals form from magma, they can form underground. They can also form from lava if it comes up. Because remember, magma is under the surface and lava is when it comes out, right? It comes up to the surface. So underground, what'd you find, a brownie point?
Supersaturation solutions for, like, is that supposed to be from or is that?
No, it's for. We get there in a minute, or it might be from, actually. Could be from. Yeah, I think you're right. We'll get there in a second. So yeah, so magma, with the rate that the magma cools and the minerals that the magma is composed of is going to determine what kind of minerals you get. So for these guys over here that were really big crystals, like this one's a great example. So this is amethyst crystal right here. In order to get this, your magma has to cool very, very slowly because it allows the crystals time to line up and keep linking in. Are you looking for that, Suju? Are you looking for that, lab? To link together and to form the repeating patterns that are necessary to get this really pretty, here, Lily, you liked this one anyway, this really pretty amethyst. So the slower the magma cools, the bigger your crystals are. And the faster it cools, obviously, the smaller they are. So supersaturated solutions, well, it should be form. So we're both wrong. Form precipitates. Okay, what's a precipitate? Who remembers? Who remembers? Okay, Bailey.
Minerals.
Mhm. Yeah, it's what kind of comes out of a solution, right?
Falls out of solution.
Yeah, it falls out of the solution. Yeah, you can think about, yeah. I can't speak some days either, so I feel your pain. Yeah, when we do chemistry lab, that we do some precipitates that are really obvious. Like you just mix some chemicals together and suddenly this solid forms balls. So precipitate in nature, right? Precipitation is stuff that falls from the sky. It can be snow, ice,
Rain.
water. Yeah, any of these things. Frogs, right?
Cats, dogs.
Yeah, all these things. Cats and dogs.
No.
There was a point yesterday where I thought we had cats and dogs.
Oodles of
Life.
Oodles and poodles. Okay. So when something,
Frogs from a nearby pond, they are dropped on you.
okay, so when something falls out of solution, it's a precipitate. And then evaporates. So last week in lab, we made crystals. And basically what we did is we sped up what would be a natural process. So think about the beautiful blue crystals that you made. Those were so pretty. I got great pictures of them. If you saw the video, they were really, really good. I got pictures and I put them up. You're looking for your lab, Drew? It's right there. Just grab it. So if you were to take that same scenario that we did in lab and put it in nature, so you'd have a solution. So you'd probably have, say you had a lake or a river, and you had those you had that particular molecule floating around because it's well dissolved. It's a solution. What did we do? What's the first thing we did with that, with our test tubes, Piper?
Heated the liquid,
And why did we do that?
so it dissolves faster.
Yep, so that when we put in more of the solute, it dissolved, because typically heating things up is going to help dissolve the solute faster. Yep,
It also increases the capacity that can be added.
it does. Very good.
The hotter something gets, the more it hold,
Mhm.
which also causes super saturated.
That's where we got. So we super saturated our solution, right? So we super saturated our solution by heating it up and adding more solute to it. So in nature, it would take a situation where you've got probably sun beating down on some solution for a long time and the longer it sits there, the longer it beats down on it, the water that's in that solution is going to evaporate, right? So it's going to become more and more concentrated, concentrated as the water evaporates. And eventually to get to the point where it's so concentrated that all that's left is the crystals, they start locking together and the water goes away. And that's what we did with the heat lamp, right? We put it under the heat lamp. We were basically mimicking what the sun does, but just making it really fast. So we got these little evaporites and they were beautiful. All right, so this one I'll give you because crystal form is a little trickier. So this is your shape and your number of sides. So when we start talking about forms of crystals, it's the shape of the crystal, the number of sides. You guys know there are like crystal road shows, right? They come all the time to this area, like rock and crystal shows, or people come and they bring all that kind of stuff.
The show's on PBS.
Yeah. So if you really like minerals and crystals and rocks and things, they have, there's one coming up, I think. But they come through, they're like a touring thing and you can go buy them and look at them and whatever. So those people are real picky about what kinds of crystals they have, obviously. So if we're talking about crystal form, we're talking about shape and the number of sides. So what is hardness? Okay, Lamb.
Hardness is a measure of how easily a mineral can be scratched.
Right, it is. And what the Mohs scale, right? Okay, this isn't Mohs from the office. That would be great if it was. Y'all know him?
Or the restaurant.
Yeah, y'all know Mohs. Remember, he's Dwight's cousin? He shows up every so often. Oh, he's funny. Okay, so your hardness is how easily it is scratched, and that is with the streak plate. So we had black streak plates, right? There's actually two other kinds. There are white ceramic ones and black ceramic ones. So you can tell somebody scratched one here and it left some streak behind. This one, whatever this was, actually scratched that glass. So what you're looking for when you're checking streak is whether it, first off, is it able to scratch the plate, or does the plate scratch it? Like, does it leave behind a streak or does it leave behind a cut, right? So there is the Mohs scale, and it's, it's kind of like any other scale where it's, got the hardest and the least hard, and there's stuff in between. And that is one way you can tell about a mineral, what it is. So how about streak color, right? You want to do that one, Liam?
Streak is the color of a mineral when it's broken up in powder.
Right. So that's what you're doing when you run it on the streak plate. You are powdering it, just the edge of it, and you're getting a color. Sometimes it's easier to see on a white streak plate and sometimes on a black streak plate. So what I have is the glass ones, and then we have the white counter paper there, and then we have the black plate. So you can compare it to both. So special properties. What kind of special properties might a mineral have that would help you identify it? James found some up there with special properties. Drew, what do you think?
I was gonna say, how do I explain it? Like, how the crystals form inside the rock.
That could be part of it.
Like if it's hollow inside.
Oh, yeah. What else? Piper.
If it's magnetic.
That's a big one. So that's what James found. James found a rock up there that was magnetic. I didn't even know that was magnetic up there. So that's one. Bailey?
If there's like sediment layers.
That's one way. What else? What you got?
If it glows under like a black light or UV light.
Yeah, that's what we're going for. So your special properties are things like magnetism, and it's also double refraction, effervescence, and fluorescence. So effervescence is if you stick it in water or another solvent or whatever, does it bubble? Some rocks are going to bubble, okay? And refraction, double refraction has to do with how the light behaves when you shine it through it. Now, fluorescence. Fluorescence is what Alex was talking about. When you put it under UV light, it glows. There's a particular mineral that y'all have all seen it, and it will fluoresce under black light. Do you know which one it is? Do you know, Bailey?
Uranium.
Uranium is one. Yeah, I wouldn't be messing with that. What else?
Radium?
Yeah, well, I wouldn't mess with uranium or iridium. Those are elements, right? But that's a good call. I'm talking about a mineral. It's in this room several times. It's right in here. So a way to test if a diamond is a real diamond is put it under UV light. So when I was teaching at school, I had a little office that had no windows. So when we went over this fluorescence thing, I piled all my students in this tiny little office. I had to like stand way in the back corner. And I took the UV light and it was dark in the room. And I shone the UV light on my ring and it will glow like a purpley blue color. It's really pretty. If your mom's got a diamond at home and you got a black light, ask her to do it for you. But the coolest thing is when you turn the light off, it will continue to glow for a few minutes. It fades out. It's really cool. And that's one way to test not just whether something is a diamond, but the quality of it. Because you can see how bright it is. When they do diamonds, they talk about how clear it is, whether or not there's inclusions, like little tiny things inside of it. And that's another thing that they check sometimes is fluorescence. So it's actually really neat to see. So density and specific gravity. Can anybody explain the difference to me? Oh, Drew, what you got?
Density is how much matter is inside of a certain thing and.
Volume,
Yes.
yep,
And gravity is the Earth's, or here would be the Earth's effect.
right. What's specific gravity? You know what that is? So that deals with density. Let's see, Piper, what have you got?
The ratio of the weight of a substance to the weight of an equal volume of water at 4 degrees Celsius.
Yeah, all that. So basically, here's the difference. Your density is how much matter is in a given volume, right? So I could take this crystal and it's how much matter is in this exact shape. Now this shape would be harder to determine the volume because length times width times height is going to be tricky on something like this, right? There are ways to do it, but say you had a cube, just make it real simple, a little wooden cube block, okay? And you want to find out whether it's going to float or sink in water, and you toss it in water, what's the little wooden block going to do? James? It's going to float. Yeah, almost
Yes.
always. Yep, unless
There are
it's
a
something
few
weird done to
words
it.
That won't, I believe.
Yeah, if you've got it like pressure treated and weirdness, that yeah. But if you've just got a wooden block, it's going to float. Why does it float? Because it's less dense than the water. Okay, so specific gravity is like your point with which you're going to compare all things when you're saying how dense. It's your standard. So if I said in this room, like, who's tall and who's short? Well, compared to what? Right? Like I could say I'm kind of short, but compared to what? So this is what you're comparing to. So it's the density of the substance divided by the density of water. Whereas if you're looking for regular just density, not specific gravity, it's the mass divided by the volume. So to get specific gravity, you need to have the density. So density is mass divided by volume, and then specific gravity, you're going to take that mass divided by volume number, and then you can divide it by the density of water at 4 degrees Celsius. Why does at 4 degrees Celsius matter? Why does it matter that you give it a specific temperature? Pepper.
So it's even among all of them, and that's
Yeah.
the most common water temperature.
What's going to happen to water if you heat it up versus cool it down where density is concerned? Alex?
It's going to change. As you heat it up, I believe it becomes less dense because it expands.
Mhm. And Drew, did you have something to add?
Yes, but generally speaking, with most elements, not water, but when you cool it down, the
Mhm.
molecules get closer together, it
Right,
shrinks, and when they up and expand.
right.
But there's hydrogen and water.
Hydrogen bonds,
Different attributes, when you freeze it, they expand more.
Yeah. So water is weird in this way. So water is different. And this is why, I mean, if it weren't for water behaving the way it behaves, we wouldn't be able to live. A lot of things wouldn't be able to live. And here's why. So yes, in general, with most things, when you warm them up, the molecules get excited and they spread out, right? When you cool them down, the molecules get less excited, it kind of compacts together to become more dense. So when you heat it up, it's less dense. When you cool it down, it's more dense. But when water reaches its freezing point, the molecules, due to their hydrogen bonds, arrange themselves in such a way that it is suddenly less dense. This is why when you put ice cubes in water, they float. And if water didn't do that, think about what would happen in frozen lakes. Like you have a lake that's frozen, okay? If that ice sank to the bottom, what would happen to all the things that live in the lake? Like they'll freeze to death. So it's necessary that water become less dense when it freezes. The water molecule and the way it functions is absolutely essential for life. We could not be here without it. And there's many, many reasons why, but that's just one. The fact that when it hits its freezing point, it spreads back out again. All right, so luster, what's luster? Caitlin?
Described as metallic or
Anybody else gonna add to it? Add to the, yeah, James. Yeah. So how it reflects light off the surface of it. So this guy is definitely reflecting the light. Okay, I can see it. This got a lot high luster, right? But like this doesn't do it as much, right? So luster is how it's reflecting light off the surface. Now, some of that jewelry up there had pearls in it. Are pearls minerals? No, are they gemstones? No, they're not. They're organic, right? They come from oysters. So a pearl forms in an oyster. Anybody know how it forms? Drew?
Sand gets inside of the oyster.
Yeah.
And you're tasting oyster and it starts, when the process is called,
Mm-hmm.
but that process of its, I think trying to get the sand out, what causes the pearl form.
Yeah, basically, if you've ever looked inside of an oyster shell, it's that beautiful, shiny, pearlized white, that mother of pearl is what they call it. And the reason it's mother of pearl is because it's the same substance that the oyster will produce to protect itself from the little grain of sand. It'll wrap the little grain of sand in it, it'll keep producing it, and that's how you get a pearl. So pearls are organic.
Pearls are oyster boogers.
Oyster boogers. That's funny. So yeah, but they judge pearls by luster too, even though they're not gemstones. They judge pearls by luster. So this is a fun one. Cleavage and fracture. Who knows this one? All right, Milo.
Fracture is a jagged edge of a rock or
Mm-hmm.
crystal,
Yeah.
and cleavage is more cubical.
Yeah, cleavage is nice flat planes. So the best example over here of something that would have to be for cleavage, I love it, is this guy. What's this one?
Obsidian.
Obsidian. Okay. If you look at this real close, and I'll put it back up there if you haven't seen it, but Lily looked at it before. You can see where it's broken off in these little flat planes. So anybody know what indigenous people use this for? What they do with them, Piper?
like spearheads or things to come.
Right. Because if you chip at it, it's gonna
okay.
come off in these nice flat pieces, and it's sharp, because this is a kind of glass. Obsidian is like glass, right?
Various ways
So-
to kill people,
Right,
essentially.
or hunt. So yeah, so obsidian has nice cleavage, and cleavage is when it comes off in a nice level plane versus fracture. If you split it, it just kind of breaks apart. Now, some of you might have rocks that you want to break open, and you can break them open. I suggest if you break them open, you cover them with a towel and cover your eyes anyway, and then whack them with a hammer somewhere
Wrap
like,
them in old saw.
yeah,
Well,
go out to your driveway or someplace. Don't do it on your hardwood floors, but you may find if you crack your rock open that it has different minerals in it. Some of it looks jagged and there's some little tiny like inclusions of minerals that'll break along planes. So look really closely when you do it. If you've got a magnifying glass, get a look. Now color's easy. We know what color is, but that's determined by the elements that are in the compound.
Another good example of cleavage is like pyrite.
Yeah, pyrite's a good one too, and mica.
Home.
Yeah, and there's mica up there. Do you see the mica? You can just peel that off in layers. Yeah.
I can see my guy everywhere.
Yeah, mica's all over now. Now, when we were down at the lake, Liam was down there and Mitchell was down there towards the bottom. I think it was you or Mitchell that was digging in that saw it was you found the mica sand. Didn't you find the mica sand?
Yeah, those sparkly.
Yeah. So the sand looked like glitter because little bits of mica had flaked off and they were in there, and it was pretty cool. So what's texture? It's an easy one. Easy, Milo.
The roughness and smoothness.
Yeah, how it feels when you touch it. So is it smooth? Is it rough? Does anybody know what pumice is? Yeah, what's pumice?
Like a rock that's filled with many small holes.
Yeah, it's a type of lava rock, right? And it's full of little tiny holes because there was air, there was oxygen and other gases in it that escaped. Does anybody know what we use pumice for? Caitlin, do you know? Maybe, I think
Oh, pumice?
flint for that. James. Yeah, so we use pumice a lot for scrubbing skin. We also use it for scrubbing stuff in the house. Uh-huh.
Scrubbing toilets and stuff.
Scrubbing toilets and stuff. Yeah, you gotta watch your porcelain. Uh-huh. What were you gonna say?
Pumice is like volcanic ash that cools
Mhm.
rapidly.
Yeah, yeah, it is. So if you ever go to like get a pedicure or you ever even go to the store and you can buy a pumice stone to scrub your feet with, kind of grody, but it's good. And then they have them, they have it so you can clean grout and tile. There's actually sticks where they take pumice and they compact it onto a stick that you can use to scrub the grout. So we use rough stuff for that kind of a purpose. So types of minerals, we got lots of types. So we can break them down into these kind of groups. And here's what it comes to with rocks. There are multiple ways to categorize. Some involve what they're made of. Some involve how quickly they cooled and where they formed in the process. Others involve how many sides the crystal has. So basically there are multiple categorizations and some of them line up with each other and some of them are just kind of separate. So we talk about silicates. They contain which two elements? Anybody want to say what mostly they are? Bailey, what you got?
They're, feldspar and quartz.
Okay, so close. Silicon and oxygen is what we're going to find in silicates. I think you were looking at a different one. We're almost there. So silicates and what you're dealing with here is a lot of the time it's just quartz. This is quartz. So it's the clear glassy stuff. All right. And those are going to contain silicon, oxygen, and some other elements. And then you've got usually four-sided pyramids is how they form. Now, oxides are going to be oxygen plus what, Caitlin?
Metal.
Right, plus a metal, any metal. What's an example of a metal that oxidizes? Jack? Iron oxidizes, great. What's another one that oxidizes? Drew?
Copper.
Copper, very good. All right, so oxidizing usually causes a change in color because it's a chemical reaction. Alex, you have a different one?
Sodium,
Odium, okay.
sorry.
What's another one, Drew?
I was gonna say, that's why the Statue of Liberty is green. It's
Right.
actually bronze.
Because she's bronze and bronze contains copper. Silver. Also, I tried to polish. I have one little ring over here that I tried to clean up this morning because I never take it out. But this is sterling silver, so it's silver, but it has some nickel in it. And this one is kind of funky looking, right? It was handmade for my mom. Her dad gave it to her, and that's a big amethyst in it. There's a place in Nova Scotia. I don't know if we're going to visit it or not when we go, but it's like a beach with a cliff, and there's just amethyst sticking out of it, like for real, just sticking out. And you can grab them. And so he had this made for her when she was, I think, 15 or 16. But she gave it to me, and I found out I'm actually allergic to nickel. So anything that has nickel in it, and most silver does to keep it stronger, I can't really wear. So I haven't worn it in years. So but you can see it. I don't know if you can tell from over there, but it's black in places. And that's because the silver oxidizes. So sulfates. Our sulfate is going to be what's obviously, I mean, this one's obvious, right? It's a sulfate ion, all right? So it's sulfur. All right, and it's going to have one or more other elements. Native elements is when it has only the element. So a good example of a native element would be what? Were you going to say one?
Diamonds.
Yeah, because there's just carbon in it. But a good example would be like a copper ore. Usually ores, you've got the metal mixed in with the rock, but copper usually goes in a vein by itself. It's the only one that does, well, it's one of the few that does that. It's the one that's best known for doing that. So that's a native element. So carbonates are something plus a carbon ion. What you got, Alex?
Metal.
Metal, you got it. So metal plus a carbon ion is going to make a carbonate. And then you got sulfide, sulfur plus one or more other. Bailey? Oh, yep. So one or more other elements. And then halides. So halides are chlorine or fluorine plus three other elements. You see them, Liam? What are they?
Calcium, sodium, or potassium.
Calcium, sodium, or potassium. So what is a halide then? Anybody know what it is? What do you say, Bailey and Piper? Sorry.
Things like table salt.
Yes, they're salts. They're salts. Okay, halides are salts. So you can have calcium chloride, sodium chloride, potassium chloride. Where do we find sodium chloride?
Everywhere.
Yeah, Jack, yeah, on the table.
salt.
Do you know where you're gonna find potassium chloride?
Bananas?
Bailey? Bananas. You ever see the low sodium salt that they put on the table for people with heart problems and blood pressure problems? Instead of being sodium chloride, it's usually potassium chloride. That's all, because it's sodium channels in your body that cause the whole issue when it comes to too much water. So that's what they're dealing with. All right, this is super cool. This is a copper mine in UK. It's Cornish, so it's in Cornwall. So it's got this wackadoodle name, right? Because Cornish has got some wackadoodle stuff. And this man, apparently for fun, he goes and just climbs through old mines. And I think he's a little crazy because he does a couple things in here that I would not do, because we're talking about an old abandoned mine with like wooden pylons holding rock up, and he just goes in on his own.
Does he kick one of the?
He doesn't kick. He's very smart about it, but it's a little crazy. It's a longer video, but the stuff you get to see is really neat.
And what stuff does he do, you know?
Well, you see, he does some kind of climbing around in places that I would not climb around in.
That
but-
makes my body tense. I can't.
Well, why don't you want to go? Hello.
Going in a old
Hold on, it's
place,
being weird at me.
a Fabulous weather now.
Yeah, and you'll never go to the kind of the cave-ins,
Like,
serial
you know,
killers,
Okay.
Like,
horrible monster that's going to destroy the world that you've.
What is it not knowing?
the copper comes up and engulfs you.
Oh, Pennywise.
Just it just emerges from the
Let's
abandoned
do
mine,
that.
like, hi, I've been waiting for someone stupid to come in.
Let's
Oh,
do,
Pennywise.
Let's do
it
this.
did okay with the other one, so let me move the other one. I don't know why it's not going, so we'll do this one instead. We'll put it, pull up this one. Okay, because it did fine over here.
Oh, yeah. 'cause
There we go.
you cave yourself in.
Yes, but if you kill the other thing with you.
All right, so you good now?
Worth it.
You
hey,
guys good?
Kill you anyways.
You guys, are you good?
Yeah.
This should work now, I hope. There it goes. Okay, here we go. Dude's just wacky.
Hello and welcome to another Benno Cam Lockdown Edition Mine Explore. Today we're having a look at Tyward Hale, which is an interesting mine. It's just up the round of Temple Tree and it's got a few interesting features in it.
Eardrums are getting destroyed.
I normally always explore with people, but
He goes in. No
today's
worries.
been an exception.
No wind.
Day. I know this mine very, very well, so it's considered pretty low risk. I've let people know where I'm going, what time I'm up there, I'm gonna leave that, so let's do it.
If you say so.
Tyward Hale mine sits on the north of a valley close to the coastal town of Porth Tower.
Doesn't take too long.
The mine's engine house on Taylor Shaft remains visible on the hilltop many miles away. And this mine had one of the first mine shafts in Cornwall to be drained using an electric pump. This mine started life as Wheel Rock in 1750, was renamed United Hills Mine in 1809, before becoming known as Tyward Hale in the early 1900s, when it started to be used as a training site for the Royal School of Mines for Imperial College in London.
Yeah. You're claustrophobic. This is for you. Yeah,
Nine.
this is cool though. This part's cool.
Shot, but
It looks-
Still.
But it definitely looks like
Left
some
in
monster
position here.
jump out and eat you.
Listen now.
And this is where we're gonna go. We're gonna go down into this lower part. Now at this point, you just get the first glimpses of the copper bearing rock.
That
which
is
surrounding
really
us.
cool.
So you can see here the copper residue slowly leaching out from the load. This is the area of metal they were after.
It doesn't even look real. It looks like somebody spray painted it.
Above us.
It's pretty cool.
And you can see these beautiful colors coming through.
Lick the alien
So there's
stuff.
obviously still some copper still in this rock.
Yeah, it looks like area.
Which they left behind.
Hmm.
They're crawled down through some stoping now. And we're gonna go right down through here and link up with the deep adit, which is a little bit narrow. As you can see, it's not the most spacious.
No.
Okay, we've reached the deep adit section of the mine now. We're gonna use this to further access the rest of the work. Okay, we finally reached stoping.
What was that?
So you can see here that
Look at this. That's wood.
this large space that's all been stoped out, go right up. There's a enough rope there that's enough for later on when we're gonna go on there. We'll go around in a full circuit.
Wow.
Yeah.
Another shaft. A lot of water coming down this side. It's a lovely copper stain, isn't it?
In it.
Try and get you a little seeky look.
In it, Summit.
It's a bit wet.
a bit, just a bit.
Few nice iron rails here underneath the floor. You can just about make out here. It's quite nice to still see the rails still in place. Not a lot of mines. They left them in, these used to pull them out as they went. That's quite nice to see. So we've got
Look at that. No, thank you.
stoping on top of stoping here, you can see.
Yeah.
Definitely a lot of ore on that this around here, let's say we're after.
So the hollow space is where the copper vein went through.
Veins right up
You
to
can see it. That's pretty cool.
wherever they needed to get it.
Yeah, I'm not going in there.
I
That
don't think
looks
they
scary.
think we're actually doing all that much, but I'm sure at the time they felt better working underneath them with them there.
It's actually going right.
Yeah, he goes right underneath this dude, doesn't care.
Nice deads here stacked up. This is all the rock that doesn't have any minerals in it. So this is all the rock that wasn't worthwhile
Rock rejects.
stacked up neatly in the sides of the stoping, which is good. And this is what we've come here to see. This is the incline skipway. So these are rails with
What a place to die.
Where's the video where he gets crushed?
tracks, metal trolley right down further deep into the mine.
That's cool. though.
Yeah.
So, pretty interesting. It's good. It's a good thing to come and have a look at.
I look like copper.
Look at
This
that.
is the trackway, and it goes right the way up there, which we're gonna actually go up this ladder now. And some of these signs have been put in
This is when I thought the man was insane.
by the mine people when they take students here from the college. They don't do that anymore now, but
He goes up.
they've left them in place.
That ladder.
These ladders go along that way. There's about
When you
I
said
think
they
3
don't do
sections of
it,
this. And we're gonna climb down now.
He's gonna want that. No,
No.
that's wood. Sides are wood.
That's
They
ancient
are
wood.
actually in very good condition.
Uh-huh.
They were,
yeah.
Tell yourself that.
they were all checked
Let me
and
tell you
not that
something.
many years ago,
Yeah.
when the school used to bring people down here.
Are we sure?
Look at
Doesn't
this.
need help?
Right?
I mean, I'm good with metal, but that's
Almost
fine.
there now.
Appears to be wood.
More steps.
Wait, look down.
And then we'll show
Oh
you.
my god.
No. Nope.
So. He said it's quite all right.
Yeah, that's good.
I'm
Nope.
good.
British people are on another level.
This guy's for sure on another level. Look. Look at that.
Oh my god.
Nope.
And then we're gonna,
Wow.
if we wanted to, it might just go further and further up this inclined skipway. We're actually gonna go along now along this middle adit level. These wooden partitions are in place to,
He's standing on a wood deck.
stop any loose stones or anything like that rattling down through.
Who does
Again,
that?
some great copper
This guy.
staining here. You can see it coming up.
British
around
people.
the-
Okay, they're British people.
read.
This dude for
I
sure.
love them so much.
That is gorgeous though. Look at that.
It is.
So pretty.
Alien slime.
Alien bar.
Look at the wood holding up the wall. Okay.
Oh yeah, another ladder.
With water all over it. Look at that tiny little ladder. Look at that.
I bet I could have just like hopped up there.
Yeah, no.
Okay, so we're now at the top of that main stope that we first came across when we got into the workings of the mine. So we're gonna use this rope here to carefully.
Why?
How long has that rope been there? It's my question.
Yeah.
I mean, it's probably
This
since
rope-
college, but still.
That's a hemp rope. That's not nylon. That's hemp. He's a little
My
crazy.
question is, the camera's there.
Yeah, got GoPros.
Still alive.
Yeah.
It's just a cool.
Yeah.
What a man.
What a man, what a man. Hey, no, YOLO. One more.
So this dude amazed me because I was like, wow, the guy, your video is worth sharing because that's insane. I can't believe you just did that. Like, that's a little crazy. I don't know what's up there. Yeah, you know,
British Bear Grylls.
he may be, but he's apparently a mine guy and that's what he does. He does mines and
He's the spelunking version of
yup,
Bear Grylls.
yep. So in that case, they were mining copper ore, right? And so you can also mine for, I know what the problem is here, I think. You can also mine for things other than ores, like you can mine for gems. So that's what this is. This next video, if it's gonna work, let me see if this was the problem last time, maybe. Okay. So this will explain why, this in particular, this is black opal. Okay, have you ever seen black opal?
But it's blue.
Yeah, it does look blue. So black opal, as this video is going to explain, is primarily found in Australia. And actually, I can't remember what it's called. There's a Facebook page I follow for this opal mining company, and they're all the time like pulling opals up and showing them online. They're really cool. James?
There's a very good smarter every day about opal mines.
Okay.
Australia.
Oh, yeah? Okay. Well, this one's interesting because it talks about the cost of mining. Like, if you're going to have an opal mine, what's the cost to you? And how much work do you have to do? And is it really worth it? So the reason that gemstones are valuable is because they are rare and they're pretty, right? It's the rareness. That's why gold, there are some videos about why gold is used for currency. Part of it is that it's malleable and it can be made into coins, sorry. But part of it is that it is so rare. Yeah, you don't find it very often. This is why when there was gold found in places, people went crazy and went there. So Dahlonega, who's been to the mine in Dahlonega? The mine is amazing, right? So there's an abandoned gold mine in Dahlonega. It's abandoned because it's no longer in use, but it's not abandoned from the point of it's now tourist attraction. So you can go down into the mine, and what they look for in looking for gold is they look for quartz veins, because gold tends to form in between the quartz veins. So when you get a vein, it's like you have rock and then there's a crack in the rock and it's filled either by a solution or by a liquid magma. It's filled by, could be just the magma itself, or it could be could be literally like a solution, like a watery stuff that fills in and then eventually dries up, evaporates out. But you get these veins, right? Like you've seen these rocks some of these rocks have veins. There's one that's a really good. Where is it? Everything got moved around. This one is, you can see layers. There was one, where is it? Shoot, I can't find that. There's one that has this one has a perfect little vein through it. So this is when you get layers. This is like one layer forms and another layer forms and another layer forms. But this little guy has a vein that goes right through it. You can see right here where there was a crack and something filled it in. So when gold fills in veins, they tend to do it around the pure silica, so the quartz, and the gold comes in there. So if you go to the mine in Dahlonega, once you get down into the mine itself, you can see these big, huge quartz, they're like tunnels of quartz where they've taken the gold out of them. And they'll move, like in that, you could see there was obviously a copper vein here and a copper vein here and rock in the middle, right? Because they mined above and below a section and then they propped it up with little chunks of wood. That's safe. So this one is about opals. And I didn't have any opals over there as an example. I think my mom has maybe one or two downstairs because they're October's birthstone, but there's also there's an alternative. I think it's a topaz or something that you can do because opals are so pricey. But this is really cool. And there's a guy talking about it because he owns the mine, he runs the mine, and it talks about how expensive it is and difficult to run. And
high quality black opal can cost over $10,000 per carat, making it one of the world's most expensive gemstones. But mining black opal isn't easy. After investing tens of thousands of dollars, a miner might not find a single gem. So what makes black opal so hard to find? And why is it so expensive? Black opal is one of the most enchanting in the world. sought after for its seemingly infinite display of colors. Compared to common opal, which is usually one color, black opal exhibits many different colors, contrasted by a dark body tone.
It's simply the most stunning gemstone on the planet. It's just remarkably beautiful. You can put the thing away for a week, pick it out and look at it, and you can still see things inside it that you've never ever seen before.
Opal is found in several parts of the world, including Ethiopia, Brazil, and Mexico. But over 90% of the world's opal comes from Australia. And a lot of the black opal is found here at Lightning Ridge. It's located on the edge of the outback, with a population of just over 2,000 people. Miners have been searching for opal here for over 100 years. But even for experts, finding black opal isn't easy.
If you were to start mining tomorrow, and once you learn mining skills, and I've been mining for 40 years, you'd be in equal chance. Just because there's nothing really that can tell you, oh, there is opal in that piece of ground, or there's not opal in that piece of ground.
Miners start by drilling a vertical shaft in an area that they think contains opal. Then they must clear out an underground room large enough to start digging out the rock.
The basic idea of mining is basically extract the opal clay out from the ground, put it onto a truck. I take the truck to a puddling site in town and check if there's opal in that.
The equipment needed to mine and the cost to register your claim can be extremely expensive.
Really, if you wanted to rock up here and be serious, you probably need 150 grand to 100 grand in your pocket.
But buying the equipment doesn't guarantee that miners will find black opal.
Some people will go, oh, there's definitely money there because next door they got $200,000 and there was a bit of colour drilled up here, it's sort of come over, and there's a whole epic story of why there should be opal there. You go and dig there and it's not.
Miners search for areas in the rock with trace amounts of opal. They follow these spots, called navies, hoping to find more opal deeper in the rock.
They'll keep going in a straight line until the trace runs out and then come back where there was trace in the wall, go left and right. And then if that's stopped, then you come back and do it again. You can come back and do it again. So you've always got that in the back of your head, you know, when do I leave? How long do I stay? Have I stayed too long? I'm wasting time, I'm wasting money for my next patch.
Lexi, my wife and kids.
It's enough. Put them in a really good pocket. See how they're not even sitting close like that together. They can be like a cluster, like a bunch of grapes are all sitting around each other and they've all got colour. Hear that? See that sound? It's like glass. So get that big one out. There we go. Doesn't have any value. Common back opal.
Opal is formed when silica-rich groundwater hardens in rock over millions of years. Large silica spheres within the stone diffract light, creating vibrant colors. That play of color makes each gem unique. But for miners like Frederick, digging for black opal is a gamble.
The human factor is the biggest factor in finding.
You're talking there.
If you've got a piggy bank of $10,000 or $20,000, and then all of a sudden in 1 month or 2 months you've blown all of that budget because you've had breakdowns and you've had things that you didn't think of, and then you go, well, I'm $20,000 down, what do I do here? I've been full-time mining for about over 45 years, and quite often I say to myself, how did you do it? You know, how did you survive that long, making it your only job? I've done
No.
not great. I haven't been in the millions. I've been up there in the fantasy pocket, you know.
Rough opal is extracted and processed from the dirt. It has to be cut and polished. This is when the real value of the gem is determined.
A black opal can vary from starting at maybe $1,000 a carat for one of your mill and going right up to tens of thousands of dollars for that really exquisite top quality. The main stone is 241 carats. A few $1,000s a carat wouldn't be unreasonable. So a lot of money.
The color, brightness, and patterns can all influence the price of black opal.
What you're looking for in the best quality opal is a black stone, really bright colour and as much red and other colours as possible. So the most valuable black opal of all is a really bright red stone on a very black base, and that just glows. And you don't see them very often at all.
That lack of supply is a huge driver for the price of black opal.
We can barely keep up with the demand at the moment. As soon as you find a gem quality stone, you know you've got to buy it for.
Between 2005 and 2006, approximately $30 million of opal was mined at Lightning Ridge. And for fans of black opal, there's simply nothing else like it.
It's just a magic stone, and when it came to the Lightning Ridge, just the beauty of it captivated me.
It's an awesome job. I would love to find 2 or 3 more good claims, like 1 more good patch, get rid of the
World's
depth that we
rarest
have,
cheese.
and set it up and offer the opportunity for my son to take over the bills.
So obviously rarity has a huge impact on how much something costs, right? Diamonds are pretty rare. They're also really, really hard, right? We use diamonds. Another way we use economic minerals is, we can use diamonds to cut things. They make diamonds like sanding wheels and stuff like that. So gemstones, like in particular diamonds, isn't just necessarily for jewelry, but we have, industrial purposes for it. But, you can see there's other opal there, and they're beautiful. I mean, they're really, really pretty. So I don't know what his deal is. Most expensive opals. So you can see there was one other I was going to show you, but okay, I don't know what's up with this thing. So about ore, all right, we talked about ore, and we talked about how the copper is just mined, right? I wanted to make sure you guys had seen this. So when a copper is mined, it's pretty much just, what did I hit? Oh, nope, go away. Okay, whoop. It's pretty much just straight copper, right? Whereas I said that other metals tend to be in the rocks, right? So here's an example. This is when we do smelting. Smelting is when you basically cook the rocks to the point where the metal that's in them will melt and come out. So when we do smelting for iron and all the other types of metals that we use for industrial purposes. So it still looks like that, this right here, like people still work in factories like that, where I would not do well. It is way too hot for me, but people still work there, and they go right up to those big smelting ovens, and they the rocks go in and the metal melts out of it.
You gotta at least use like some heat-proof stuff.
Oh, they do. They have gloves and suits and everything. But that's still a job. That's still a big job. And there's some places up in the north, like in Pennsylvania, where this was a really big deal. This was one of their major industries, was steel production, which involves melting down iron and whatnot. And yeah, that's why the Pittsburgh is the Steelers, right? Because of that. But before we had big involved smelting ovens like this one here, we had these little dudes at the top. This is called a bloomery. So this is old school back in the day. Like, how did we get iron swords? How do we make metal? Our metal age, we got into the iron age. Like, how do we figure that out? How do we melt metal out of rocks? Well, this is how we did it, with these little kind of bell-shaped ovens with a tiny little chimney. So you can imagine that if you light a fire in there, the heat's going to be really well contained because of the shape of it, right? So we would build these little ovens, these bloomeries, with stone all around them. And then we would, we'd throw in the ore, and you heat it up to the point where you can separate the metal from the remainder. And the remainder is called slag. And that's true in with glass work too. Like if you go and do any kind of glass work or whatever, there's pieces that fall off into the bottom of the oven. And when those get pulled out, that's called slag. It's the leftover stuff. And in like the 50s and 60s, actually earlier than that even too, it was very popular to take that slag, melt it back down, and make stuff out of it. It's usually a thicker, kind of like a lower quality item, but they make plates and pitchers and cups and things with slag glass. Sometimes they're multiple colors. And the slag that comes out of this is kind of useless for the purpose of smelting and working with metal and metallurgy in general. So this little oven, we'd heat it up good. And that's wild. That's how we did it. If you've ever wondered, like, how do we do it? And the bloom, see, it says bloom right there. They called the slag bloom, so that's why it's a bloomery. So that's how we would get metal out of rocks. That's where our ore, that's how we separate it from the ore. So when we're looking at, which one is you? That's one of you. So much here. Ay, ay, ay. So there. So if we look at your binder work, let's go over that and see what we've got. So we've kind of gone through most of these definitions already. So here they are again. So what we want here is a true or a false. And first question, minerals. They can come from cooling of magma. Is that true or false?
True.
That's going to be true, right? Okay, what's the other way minerals form?
Evaporation.
Solutions, yeah. Solutions, magma, right? All right. So density differences can force magma upward into cooler layers of the Earth's interior. What do you got, Bailey?
True.
Yep, you got true. Okay, that's true. So magma is going to be like any fluid. It's not necessarily consistent. Magma can be made up of multiple types of minerals that are, because multiple types of rocks melted. So it will settle out like anything else, where the denser parts will come to the bottom, the less dense parts will go to the top. So if the magma cools slowly, atoms do not have time to arrange themselves into large crystals. Piper.
False.
So if the magma cools slowly, I can't speak, that's when you have lots of time for the crystals to arrange, make their really pretty, lovely stuff. All right, so the next one is small crystals form rapidly from cooling magma. Liam.
True.
Okay, when liquid evaporates from a solution, the remaining elements cannot form crystals. Caitlin.
False.
Right, so what happens when the liquid evaporates from salt water, for example?
You get salt.
You get salt left and it's in crystal form, right? All right, so minerals can form from elements dissolved in a solution. Somebody else. Yeah, Parker.
True.
Yeah, right. Okay. And then if a solution remains unsaturated, minerals can precipitate. What you got, Caitlin?
False.
There you go. So it has to be pretty saturated for the minerals to come together and fall out of the solution, right? So these are our mineral groups. And this is, again, like I said, one way to classify. You're going to find more and more and more. Next week, we're going to get into this Bowen's reaction series, which talks about what cools when and how quickly and whatever. Are you all right? Okay. So what do we have for number 17? This is something that includes calcite, dolomite. What have we got? Yeah, Piper.
Carbonates.
Okay, so we got carbonates there. Very good, carbonates. All right, Alex, put them down, man. It says distraction. Just keep one like a normal human. There we go. Okay, and that one goes over there too. Thank you. All right. Piper had one or two over there. Okay, now we're like a person. All right, so what forms readily from silica tetrahedrons? Piper.
Silicates.
There you go, silicates. All right, so this is your stuff like your quartz, right? All right, how about this next one here? Composed of one or more metallic elements with the carbonate compound. Bailey.
Carbonate.
Okay, there we go, again. So composed of silicon, oxygen, and other elements. Caitlin? Yep, silicates again. All right, and then compounds of oxygen and metal. Jack.
Oxides, eh?
There you go, oxides, good job. All right, how about magnetite and hematite are both sources of iron, are examples of what, Liam?
Oxides.
There we go, oxides. Good. Okay, how about the most common minerals? Feldspar and quartz are examples of Bailey. There you go, silicates. And primary minerals in limestone and marble are what, Alex?
Carbonates.
There we go, carbonates. All right, so do you guys remember, any of you that did, quit, dude. Any of you that did, those of you that were here for chemistry, do you remember lime water? Yeah, it was like basically calcium water. Yeah, because that's what limestone is. So also limestone, if you've ever been in a cave that has a lot of like stalactites and stalagmites, sometimes those are limestone and they're really, really cool.
Also, limestone does not taste like limes.
No, it does not taste.
Sandstone does not taste like.
I don't believe it does. No. Yeah, have you been looking at limestone?
I can neither confirm nor deny that position.
Oh, my.
I can tell you it doesn't taste like limes.
Mhm.
There's a lot of lime soda.
I would assume, that it does not, because it's rock. Yeah, I mean, you know, I worry about you sometimes,
If you're going
you
to
know?
go with an expectation that it's not gonna taste like a rock, I think that speaks more to your character.
Yeah. Okay, then.
This rock won't taste like a rock. Oh my god.
Well, salt doesn't taste like a rock.
So would anybody volunteer to read this paragraph, putting the correct words in as we go? Okay, Bailey, you go ahead.
Geologists use physical properties to identify minerals. For example, the color of a mineral is caused by the presence of different trace elements.
Mhm.
When a mineral reflects light from its surface is called luster, which is described as metallic or non-metallic. When a mineral feels the touch is called texture. Mineral streak is the color of the mineral when it is broken up and powdered. A measure of how easily a mineral is scratched is called hardness. That's the first.
Good job. That's great. Anybody else want to read the second paragraph? Caitlin.
Another property describes how a mineral will break. If a mineral splits equally and continues along one or more planes, it has the property of cleavage.
Mhm.
While minerals that break along jagged edges are said to have fracture. The density of a mineral is usually expressed as specific gravity, which is the ratio of the weight of a substance to the weight of an equal volume of water at 4 degrees Celsius.
Awesome. So why do we describe the density of minerals using specific gravity? Why do we do it that way? Chloe, was it your hand? No, you were messing with him. Anybody? Alex? Okay. Oh, wait, let Chloe answer. Can you answer? It's, why do we use specific gravity to describe the density of minerals as opposed to just density itself?
More exactly.
That's one way. Alex, what are you gonna add?
It gives a baseline. It gives
Yeah.
you to compare by.
As a standard to compare to, a control, yeah, a standard to compare things to, and that's important. So you're very excited about your stack. All right. So anybody want to give me, who can give me number 9? This is explaining. So can all minerals produce a streak on a porcelain plate? Why or why not? Drew,
No, it depends on hardness.
depends on the hardness. Very good. Explain that to me. If it's like,
And the process,
well, yeah, like why with the porcelain plate? Why would it matter? How can you, what am I trying to phrase here? So if it doesn't produce a streak, what does that mean?
that means the porcelain plate is harder than mineral.
No, if it produces a streak, the plate's gonna be harder, because then when you crush it on the plate, right? But if it doesn't produce a streak, it's harder than the plate. Right, okay, good. Anybody have something to add to that or no? That's pretty thorough. Okay, so how about the next one? Step it down. Hello. There. All right. Can minerals with cleavage have more than one cleavage plane? And if so, give an example. James. Mm-hmm.
Yeah.
Like the obsidian and the mica, yeah, multiple planes, right? So halite's another example. Cubic. So it has, yeah. So halite being cubic has 3 planes. So if you break salt, it always breaks into nice flat pieces. They may be tiny, tiny, and you can't tell unless you have a microscope, but they're always nice, even planes. Okay, so what's the difference again? Somebody give it to me again. Gravity and specific gravity. Okay, Caitlin, do it again. Tell me again. We're gonna nail this into our heads.
The really technical term, I guess, is density is mass per unit of volume.
Mm-hmm.
Specific gravity is the ratio of mass of a substance to the mass of equal volume of water at 4 degrees.
Yeah, that's pretty good. That's pretty good. Very good. So yeah. So if you wanted to know what they look like, that's what the formulas look like. So density we give as a P. I don't know why we give it as a P, but it's P. P equals M over V, mass over volume. Specific gravity we use as G. And that's P of your substance divided by P of water at 4 degrees Celsius. So if you wanted to write it out as a formula, this would be the way you would write it out. When we do physical science next year, you'll see a lot of this M over V, and we use them a lot. If you ever see there's some little triangles that show you how to do the equations for like Newton's laws. Those are great. They're really helpful. But mass is always the lowercase m, volume is always an uppercase V. There's a lot of little things like that, and now you write it. But we write it to P, and it's usually like a little italicized looking P. It's probably a Greek P, I don't honestly know, but yeah, it's always a little P. Why? I don't know. So how about this last one here? How many minerals are represented on Mohs scale of mineral hardness? And what range of hardness are those minerals? All right, Chloe?
The range is. Very times it. The range is 1 to 10, I think.
Yep. So it goes by hardness. And then anybody else want to add something to it? Yeah. Okay, Alex?
As for what's on the scale, all of it, just all minerals.
Everything's on there. All right, James?
There's 14 things on the scale of the book.
14 things in the book. Okay, very good, very good. So you got this Mohs scale, and these are the 10 things that they put on it when they're doing just sort of the 1 to 10 ranking. So talc, what do we use talc for?
Isn't it used in what,
Didn't-
it's like baby powder?
It's powder. Yeah, it's baby powder, Gold Bond, any of that. If you use powder, it's very often talc. So that's going to be your absolute softest, because you can touch talc with your thumb and it just comes off, right? So talc, gypsum. Y'all saw the gypsum over here? This is the gypsum. Sometimes it forms like this. Where's the other one? I don't know what the other one is. There's a bigger one. Anyway, sometimes it forms like this. You saw this little guy? And they call this a desert rose, but it's gypsum. And it's relatively soft. If I whacked it with a hammer or even pushed on it real hard, I could damage all these really pretty little structures. And this is what they used to make drywall. So if you've ever like scratched drywall, like when it's open, not when the paper's on the outside. If you've ever done any drywall work, it's plasterish, right? Like you can scratch it with your thumb, but it won't come off with your finger like talc does, right? And then calcite, and that's a little firmer. And then apatite, there's apatite over there. I think it's.
You missed fluoride.
Oh yeah, I missed fluoride. I'm sorry, fluoride, apatite. I don't know if I have any fluoride over there. I'm pretty sure I have apatite. I love that. It sounds like you're hungry. Appetite. I think
It's not
yeah, it's these.
That would be.
Yeah, this stuff here, this is the appetite. Really pretty blue.
Appetite for destruction.
Yeah, hey man, that's a good album. Appetite for Destruction. Oh my gosh, I love it. Yeah, so that's appetite. And appetite, there are different colors, but the blue I think is the most common. And you can see that there's appetite. So yeah, I have some over there. Fluoride, I don't think I have any fluoride over there. It tends to be, I think it's yellow, if I'm not wrong. Yeah, it's kind of the green. I do have some fluoride. I forgot. It's this one here. It's the kind of greeny, there you go. This stuff, kind of greeny blue. This is the fluoride. So this is a little softer than the apatite. So fluoride, apatite.
We have some toothpaste out of it.
Nah, feldspar, you're gonna find feldspar like in your granite. And then quartz, which there's a ton of quartz over there. I'm sure you guys saw the quartz. We got quartz in multiple colors. We got rose quartz and we've got clear quartz, and this is the quartz, right? Quartz, and this one's a really sheer quartz with some kind of inclusion. So quartz is very firm. And then we got these other dudes, corundum and diamond. Yeah.
What is the hardness of a human tooth?
I have no idea. Let me see.
It cannot be that.
Where was it? Well, it's not a mineral, so technically it wouldn't go on Mohs scale, but let me see.
If it
Mohs
were to be compared,
scale, human tooth. I mean, technically it doesn't go there because, well, Mohs died on me. Scale, human tooth.
I mean, I've chipped my tooth a bunch of times.
It's a 5. So a human tooth is a 5, so that guy
I'm
got
gonna take a bite out of fluoride, the fluoride.
1,
is
2, 3, 4, 5,
I-
around appetite. Yeah, you should be able to bite fluoride, but let's not do it. Uh-huh. No, there you go. The fluoride, guys, stop with pillows. The fluoride molecule is actually part of your enamel. It's part of the structure of your enamel. So we toss more fluoride in there to try and get your enamel stronger. When you go to the dentist, you ever do the fluoride treatment? They put it in the little tray and you just bite it for a few minutes. I think now it's a foam. It used to be a gel. And they do it for kids generally, like insurance will cover it. It's free for kids to do. And they tell you pick a flavor. It's a little foam tray and you bite it. Anybody ever done that? No?
I've had
So-
it painted onto cheese.
Yeah. Well, then sometimes they paint it on too. Yeah, like the
We get
case.
painted on.
Yeah, there's that too. So, when I was a kid, it was a gel and they would put both of those trays in your mouth. You sit there, they gave you a cup and you'd sit there and like drip into the cup. It was gross, but you could pick flavors. They had like 10 different flavors.
And most of them don't actually taste like what they're supposed to.
Yeah, they don't, but,
Favorite thing about the dentist.
they don't cover it for adults typically, but I pay for it every time because I have a tooth enamel that just doesn't like to exist. So I'm like, let's please put more fluoride in there. Yeah, I don't, sometimes with like for people that are cavity prone, it has to do with, yes, how the minerals in your teeth will form, obviously. But not just hygiene. It can be whether your teeth have deep grooves in them and whether your saliva is more acidic. And if you're somebody who has the combination of those two, just like me, you get a million cavities. Interestingly, we're talking about minerals. So minerals will settle into your body when you consume them, right? So you'll have minerals in your bones, minerals in your teeth, right? Minerals are everywhere in your body. They've come up with some cool forensic stuff now where they can identify where someone is from based on minerals in their teeth. So I'm talking like they can narrow it down to a state or region of a state or a country just based on what exposure to minerals people typically get as children and then through their adult life. So they can even say like, okay, we found a Jane Doe on the side of the road and as a child, she probably lived in Florida, but then as an adult, she moved somewhere to the Northwest. And they could tell that there's some minerals that settle in your teeth. It's pretty cool. It's really cool, actually. So this last page here. So identifying minerals. So identification tests for minerals are based on their what? Caitlin, physical and chemical properties. Okay, let's expand on that for a minute. What would be, okay, I'm gonna take the appetite here. What is a physical property of this appetite? Liam,
Color.
who agrees? Who agrees that color is a physical property? Who agrees that it's a chemical property? Oh, okay. Oh, poor Liam. Why is it a chemical property, Parker? Do you know why it's a chemical property? No?
I just know what it is.
Okay. Why is it a chemical property? Piper?
Because the chemicals in it change what color it is.
Correct. So the chemicals in the appetite determine the color. And color is also a chemical property because color change is a sign of a chemical reaction, right? Okay, so we got color. Color's a good one. All right, what else do we have? What's a physical property? Caitlin?
The texture.
Texture's a good one. All right, James? Hardness is a good one. Yeah, Bailey? The what? Size. Okay, those are all good. These are all really good examples of your physical properties here. All right, so then chemical properties, we got color. What else could we test? Piper?
Density?
It's a good one. We could test density. That's physical. We could test it. Drew?
Light refraction?
There's a good one. Light refraction. That's kind of physical. Liam?
Magnetism.
Magnetism is a good one. Yeah, that's a physical property. That's a good one too. All right, James. Yes. Okay. Effervescence. That's what we're looking for. So effervescence is, Alex, geez, effervescence is a good quality we could test. We could put this in water. or in an acid or something. I see, does it bubble, right? That's a good one. Also fluorescence. If we put it under black light, does it go and shine for us, right? All right, so
I got one.
what?
Iridescence.
Oh, yeah, that's a light refraction thing. That's a luster thing. Yep, okay. So the appearance of milky quartz is caused by what? Milky quartz. Caitlin.
Trapped bubbles of gas in the
Right. So we've got quartz over here. We've got quartz that looks like this. Okay, here's great examples of, okay, these are all quartz. This one, it's almost like glass. It's got an inclusion, it's got some inclusions and things are stuck in it. You can see it, like, right? It's almost clear as can be. So very little gas in that one. Then we got these two guys. I can see through them. This one I can see through. This one a little less. You can see where there's some fracture going on in there. It's kind of like chunked up a bit. But where this one, you can see the light right through it. So these have less gas in them. But when you get to these guys, whoop, comes through it. Those are still quartz, but air. We got gas in here. Tiny, 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 tiny bubbles of gas. But that's going to cause the light refraction when it hits it, right? So it's going to look milky and not clear. Very good. Okay, let's see. Yeah, I added that. Yes, I know. Okay, well, didn't mean to do that one yet. Hey, go back. All right, so minerals hardness with respect to other minerals is, we said, Liam.
The Mohs scale of hardness.
Mohs scale, right? That's our Mohs scale. So that's what we're going to compare it to. And we're trying to figure out how hard it is. Okay, so minerals break along planes where atomic bonds are what, Jack? Yeah, okay, so yeah. So this is why you're going to see the minerals that have weaker bonds. You're going to see them slice right along those planes. If the bonds are really strong, they're not going to do that. You're going to get this like fractured look where they just kind of come apart. Liam, were you going to add something to that, or?
No, I was gonna say the next one is fracture.
Okay, the next one is fracture. So minerals such as quartz break along jagged edges and they're said to have fracture. So here's a question. You're designing your house. And where did I throw it? Right there. You're designing your dream home, all right? And your contractor comes in and says, we are going to put your countertop in next week. So we have some choices for material. You can have a countertop that is solid obsidian, or you can have a countertop that is solid quartz. What do you want?
Obsidian.
Who wants obsidian and who wants quartz? Let's see. Who wants obsidian for their countertop?
That'd be cool.
Super gorgeous, right? Who wants quartz? Oh, quartz. Why do you want obsidian versus quartz? Who voted for obsidian? Why do you want it? Why? Because it's really pretty, right? Yeah.
Because it has cleavage and it breaks along even planes.
Yeah. So what happens if you drop, you pull your big heavy KitchenAid mixer out of the cabinet, you go to set it down on your counter and you drop it, what's going to happen?
It's all gonna break.
It's gonna break. Yeah, it could break, right? Because the bonds are weaker. It's not as strong of a mineral. It's not as strong of a rock. So it's
Yeah.
essentially glass, right?
Obsidian is actually very fragile.
Yeah, it's glass.
Rock.
I mean, you can't see through it because it's black, but it's basically glass. And it's
Yes.
they call it volcanic glass, right? And you know how glass breaks. Now that's another thing to think about. When they manufacture glass, what mineral is primarily what's in the glass? Do you know, Drew?
But sand
Right, which is what? Do you know what it is?
mixture of also.
Yeah, but do you know what we're trying to use to make the glass specifically?
Melted?
Do you know?
Silica.
It's the silica. Yeah, okay, that's what we're looking for, is the silica. So that's why, remember, because this quartz here, the one I just showed you, this quartz is, dropped it. This quartz is silica, right? This is what we want when we make glass. They take the sand, yep, but they're looking for the silica because the silica is the nice, clear, strong stuff. Now glass, if we break this window, it's gonna break into shards and it's gonna be terrible.
Oh, we're breaking the window?
But think about what car accident glass looks like. Anybody ever really looked at it? What is it, James?
It's like these little.
Yeah, it breaks into little cubes. That's because they've made it safer. They call it tempered glass. They've made it so that when it fractures along specific lines so that it doesn't make giant shards that stab you in the car. It makes nice little cubes that are less likely to cut and cause damage. Yeah. Yeah. Do you have a question or?
It says inclusions on the screen.
Yeah, because inclusions can also cause the milky. Yeah.
Windshield glass is also even stronger and harder to break.
Yep.
Although you can use spark plug ceramic to break it. A bit of spark.
I never
plug
thought about
ceramic
that. Yeah.
Can break right through it.
They also have those little punches. Have you seen them? Those
Yeah.
are cool. Yep. What were you gonna say?
I've seen the broken glass way up close,
Mm-hmm.
too close.
Oh, yeah.
It's like right next to me.
Yep.
Paper flew like a rock into my window.
Oh,
And I remember James laughing at me as I was
geez, Jane.
Throwing you
Yeah.
under the bus.
Right. So it's important that they manufacture glass and it's silica, but they manufacture it differently. And they allow for the bonds in that tempered glass to be, careful, Pepper, to be weaker so that it doesn't cause issues with breaking.
There's no need.
All right,
to
so-
do that. Please just
Whoops,
get out
I
of there.
didn't mean to do that. So this next one here, the ratio of weight of a substance, the weight of equal amount of water, we've done this 50 times today, that is specific gravity. You guys should know it. All right, so this last little bit before it's time to go. So in double refraction, what happens to light? Okay, Liam,
It's bent in two directions.
it's bent in two directions. So yes, it goes whoops, it goes instead of straight through, right? And that some minerals are gonna allow for that. And that's one way to test for them. So calcite bubbles when it comes in contact with hydrochloric acid because calcite releases what? Caitlin,
CO2 in the form of.
yes, this is basically why we get, so limestone will dissolve slowly over time because rain is slightly acidic very often. And it's acidic because it comes through the air and it picks up other molecules, which shifts the pH of a raindrop from completely neutral to slightly acidic. And it-
when it isn't, it can still act as both.
Yeah, it can still act as a solvent, but when it's acidic, it's even more. Last one. So lodestone can pick up iron filings. So what quality does it have? Lilo. Yeah, it's magnetic. That's great. I like how it says a rotten egg smell. That is definitely not what we're looking for.
Yeah.
Sticky texture.
Okay, so here's the deal. Be sure that you have put your lab from last week in the folder. I have to give back a couple things. Don't go running. Let's see. I have 2 winners because I didn't give James his last week. So we had James. I'm gonna put it here for you. We have James, and then we had. What's the other one we had? Oh, wait, that's-
Chloe's story. Oh, and she like, oh yeah, James
that
laughed.
was James. This is from last week, I think. And then we had Chloe. Yeah, where's Chloe? You guys gotta see Chloe. Hold on. This is somebody.
It's
Liam,
off.
that's you. Okay. These belong to other people.
Just for getting
This is Chloe.
called
That was
out.
pretty awesome. So I love it. I love it. I've had him made into Ariana Grande, Professor Snape, all kinds of fun things. So.
That's how we think. Oh, I got so many. Alex,
Like-
I got so many. Alex, you
Tiger,
want some more?
Caitlin,
Yes.
oh, I got you. Milo, you all got stuff over here.
I forgot.
Pepper James, Caitlin, Jack,
I
Milo.
played my hand for earlier.
I got one.
Oh, okay, well, you can send it to me as a PDF before the end of the day.
Also posted answers just for.
Excellent, thank you. And the video is posted, so you guys should be able to get data from that too, for the most part. All right. Oh, that's a nice. Come here, come here. That's my boy. Everybody go back to
Miss Danny?
Yes, sir.
I haven't gotten my last one. I'll email it.
That's
today
fine.
or tomorrow.
Send it, yeah, send it tonight, or tomorrow, because you were out last week, so you're fine. Who's here? Oh, yeah, no, oh, yeah. Oh, yes. You're Nicky dog. You're a good one. You get that. You get that. You're in the mud today.
Hard dog, real easy.
Oh, you're Nicky boy. Here they go. They're getting candy. You know what that means? Probably was, and we did it a long time.
They're very good too.
Yeah, they are.
Step on my foot when it's too tight.
Hiding out there, don't be everybody.
Yeah.
You did what? But did you sign and count it? Yeah. So we're on check. It's all,
Where's my lunch box?
I'm done, they don't want your stuff.
Can't find her rock.
Hey, man, rock.
You gotta put it back.
There's a bag over here. Put that.
Oh, my.
Okay. Okay, that's a rock. Okay, then. Like, somebody's having more with the plate and on it. We ate way too much. Green and black, it's all over our bed. It was awful, because not only did he like get sick, but then he like scoops, trying to like trails, but it was everywhere.
I know. I need this. I gave her, it was a little,
Yeah.
I got this.
That's funny. Pizza. Good.
Oh, yes.
Yeah. That's what I like to do. Yeah, they still have me bad. Oh, the building is small. Yeah. Yeah, you know, I got you were, you know, and then on. You do like for you. Thank you. Then like that. Hey.
I'm gonna go get my shoes just to get to the top of that.
Is Okay.
Oh, I forgot to turn this off. Lily's still watching everybody leave. Okay, sorry about that.